Hi, I'm Wally Andrews, and I'm going to be talking about conjugate acids and bases, as well as the process of neutralization.
Hi, I'm Gavin Abernathy, and I'm going to be talking about compare and contrast Arrhenius and Bronsted-Lowry, and also strong and weak acids.
Hi, I'm Nicholas Teglin, and I'm going to be talking about the Arrhenius definition of acids and bases and the Bronsted-Lowry definition.
My name is Gunnar Talke. I'm going to give you some examples of acids as well as their properties. Bases and acids. Here are some basic examples. Cleaners, like most household cleaners, have ammonia in them. Baking soda is simply sodium bicarbonate, and calcium hydroxide is lime. Not like lime, the fruit, but lime is in lime still. And acetic acid, which is vinegar, well, it's an acid. Same with citric acid, sulfuric acid, and hydrochloric acid. Now, all of these have their own special properties. Tastes, for example, acids are much more of a sour, kind of not good taste, while bitters are a very strong, tart taste. Acids conduct electricity extremely well. That's why they're used for battery acids. Indicators, they're sort of a way to show off how strong of a pH it is. If a certain indicator shows a different color, you know how strong a pH is of something. Neutralization. Acids are neutralized by the bases. That's why they're often used to counteract each other, because they give the hydrogens to the other, canceling out the actions. Touch. Acids burn, while bases feel very slippery, and in reactions with metal, acids will corrode the metals, while bases won't have much of a reaction at all.
Neutralization is when an acid and a base mix. During neutralization, the acid and the base's properties will cancel out, leaving behind a salt. Neither the properties of the acid or the properties of the base will remain.
The Arrhenius definition of acids and bases. An acid is a substance that dissociates in water to produce hydrogen ions, and a base is a substance that dissociates in water to produce hydroxide ions. The Bronsted-Lowry definition. An acid is any substance that can donate a hydrogen atom, and a base is any substance that can accept a hydrogen ion.
Compare and contrast Arrhenius and Bronsted-Lowry. Arrhenius acid dissociates in water to produce hydrogen ions. Equation 1, H plus OH negative goes to H2O. Equation 2, HCl plus NaOH goes to H2O NaCl and is useful. Bronsted-Lowry restricts acids and bases to water solutions. Acid can donate H plus ions, base can accept H plus ions.
Every acid has a conjugate base, and every base has a conjugate acid. When an acid loses a hydrogen atom, they turn into their conjugate base, and vice versa. If a base gains a hydrogen atom, they turn into their conjugate acid. Each and every single acid and base have a conjugate acid or base.
Strong and weak acids. Some of the strong acids include hydrochloric acid, hydroiodic acid, and hydrobromic acid. Some of the weak acids include formic, acetic, and trichloroacetic.
Hi, we learned about how salts are made and what a conjugate acid and base are.
For me, you learned some basic acids and bases in everyday things and what they do.
For me, you learned the definitions.
From me, you learned how to compare and contrast Nick's definitions and also strong and weak acids.
Thank you for